Have you ever noticed how a group of informed opinions often leads to a better decision than relying on just one expert, even a brilliant one? This powerful principle is exactly what ensemble methods leverage in machine learning, combining multiple models to achieve superior performance. When using ensemble methods, you weigh predictions by assigning different levels of importance or influence to the output of each individual model before combining them. The goal is to leverage the strengths of diverse models and mitigate their weaknesses, ultimately leading to more robust and accurate overall predictions. The core reason behind weighting is rooted in statistical theory, specifically the bias-variance trade-off. Individual models might exhibit high bias or high variance. By combining them, we aim to reduce both. A well-chosen weighting scheme can amplify the contributions of more accurate or less biased models, while suppressing those that might be less reliable or prone to overfitting on specific data patterns. It is about creating a collective intelligence that is greater than the sum of its parts. There are several practical approaches to weighting predictions. For classification tasks, you might use soft voting, where each model outputs a probability distribution, and you average these probabilities, potentially weighting them based on each model's historical accuracy. For regression, a common technique is to take a weighted average of the individual model's numerical predictions. A more advanced method is to use a meta-learner, also known as a stacker, which is itself a machine learning model trained to learn the optimal weights or combination strategy from the outputs of the base models. This stacker essentially learns how reliable each base model is under different conditions. One insider technique is using cross-validation error or out-of-bag error estimates to determine these weights. For example, a model that performs consistently well on unseen data during cross-validation might receive a higher weight. Another sophisticated approach involves optimizing the weights directly as part of the ensemble training process, minimizing a chosen loss function, such as mean squared error or MSE4 regression, or cross-entropy 4 classification. This optimization can be done through techniques like gradient descent, treating the weights as learnable parameters. Ultimately, strategically weighting predictions in ensemble methods allows you to fine-tune your model's collective intelligence. It moves beyond simple averaging, enabling your system to intelligently prioritize insights from your most reliable components. This leads to predictions that are not only more accurate but also more resilient to noisy data and unexpected variations, making your machine learning solutions more dependable and powerful.